Section 7.1, the basics of solving quadratic equations. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. The equation is in standard form if a is greater than 0, if a is positive. So we want to solve these quadratic equations. So the first thing we need to know is we have to have equal 0. We cannot have equal 24. So we're going to subtract 24 from both sides. X squared plus 2x minus 24 equals 0. Now we're going to try to factor this quadratic. We can factor it. It's going to be plus 6 and minus 4. So now if the product of two numbers equals 0, then one of them must be 0. Set each factor individually equal to 0. You get x equals negative 6, x equals 4. Find the x-intercepts of this quadratic. An x-intercept is a point on the x-axis. So if you think about a point on the x-axis, you might have the point 1, 0. You might have the point 2, 0. You might have the point negative 1, 0. Notice that y is always 0. Y is the same thing as f of x, so we're going to say 0 equals x squared plus 2x minus 24. Wait a minute, that's the same thing we had here. 0 equals 2x. X squared plus 2x minus 24 equals 0. Same thing, 0 equals x squared plus 2x minus 24. So, what were our solutions? Negative 6 and 4. Negative 6 and 4. So, x equals negative 6 and 4. So, what are the x-intercepts? Well, there'll be one over here, negative 6, 0, and there will be one over here, 4, 0. So notice we had to find really the same two values, negative 6 and 4. We just were asked for it in a different way. The first time we were told to solve the equation. This time we were told to find the x-intercepts. Let's solve this equation. There are two ways to solve this equation. I'm going to use the factoring method. So we'll subtract 49 from both sides. Factor. Set each factor equal to 0 and solve. Negative 7, positive 7. There's another way to solve this problem that we'll talk about in just a minute. But for now, let's talk about a different way of answering the same question. Suppose it asked us to find the x-intercepts of f of x equals x squared minus 9x. Once again, if it's an x-intercept, then y equals 0, or f of x equals 0. You get this problem, which you solve in exactly the same way. So we need to know that the answer is a positive or a negative 7, and we'll just put the plus minus there to show that it's either positive or negative. The principle of square roots. So if you have an equation of the form x squared equals d, where d is some number, then the solution will be the square root of d or minus the square root of d. So let's think about the kinds of solutions we might get for this type of problem. If you had x squared equals 9, it would be x equals plus or minus 3. If you have x squared equals 5, it'd be plus or minus square root of 5. So if D is positive, then the solutions are real numbers. We like them. When D equals 0, the only solution is 0. When D is less than 0, when D is negative, so you'd have something like x squared equals negative 1. The solutions are complex or imaginary. So here's the same problem we had above. We had x squared equals 49. And we went through and we factored, but now that we have this principle of square roots, we can jump straight to the solution. X is plus or minus the square root of 49. So x is plus or minus 7. That's a whole lot quicker way to solve this type of problem. So let's solve equations of the form x squared equals d using that principle of square roots. Give the exact solution and approximate the solution to 3 decimal places. We like to have 3 decimal places in math in this class just to show that we know what we're doing. We know what the numbers are. So we have x squared minus 2 equals 0. We want it to be in the form x squared equals a number. So we're going to add 2 to both sides so that x then becomes plus or minus the square root of 2. Our approximation for that using a calculator is, so it's approximately 1.414. We're going to stop there. It's 1.4142136. It's an irrational decimal that doesn't repeat a pattern and doesn't ever stop. So let's go on to the next problem. 7x squared equals 3. We need to get it in the form x squared equals some number. So we'll divide both sides by 7 to isolate the x squared. That gives us x squared equals 3/7. So x is plus or minus square root of 3/7. And we take the square root of 3/7 on my calculator, which is kind of sad. I have 3 divided by 7. That's 0.42857. And then we take the square root, 0.654, but the next number is 6, so it's 0.655. X is approximately 0.655. I like this method. It's a whole lot faster. But first, we always have to isolate the square, x squared. So add 6 to both sides. Divide both sides by 5. X squared is 6/5. Take the square root of both sides. Remember to take the plus and negative, positive and negative square root. So this is our exact answer, plus or minus the square root of 6 divided by 5. 6 divided by 5 is 1.2, so we take the square root of that, and we get 1.095. 1.095. That's our approximate answer, 1.095. We want to solve this problem in the same way. So it's not exactly x squared equals something, but it's some expression containing x. That's squared equaling a number. So we can go ahead and take the square root of both sides, but we have x minus 11 on the left now equals plus or minus the square root of 18. Add 11 to both sides, and we have 11 plus or minus the square root of 18. We can simplify the square root of 18, so we should. 18 is 9 times 2, so we want x to be 11 plus or minus 3 times the square root of 2. And that's our answer. Using that same idea, x squared plus 6x plus 9, that's a special product. That factors into x plus 3 quantity squared. That equals 11. So now, same as before, we take the square root of both sides. X plus 3 equals plus or minus square root of 11. Isolate x now, subtract 3 from both sides. You have minus 3 plus or minus square root of 11. So that's our solution. So let's solve some equations of this form. Solve equations of the form x plus a value squared equals d using the principle of square roots. So we just did that. We just solved using the principle of square roots. We got it into the form where it was something squared equals a number, and we just took the square root, the plus, positive, and negative square root of both sides. Completing the square is a way of transforming a quadratic equation of the form x plus c squared, quantity squared, equals d. Then solve the equation using the principle of the square roots. So what we're doing is we're fixing the left-hand side so that it is a perfect square, so that it is a special product, really. It's got to be something squared. So let's look at this. We have x squared plus 6x equals 2. So up above we had x squared plus 6x plus 9. That was kind of nice because we recognized that as a perfect square. It was x plus 3 squared. So we like it when it can be factored in the form like this. The problem with this, what we have here, is we don't have the plus 9. I wish we did. X squared plus 6x. Suppose we just add that 9 on the left, but then we have to add the 9 on the right. Then this factors, just like it did before, as x plus 3 squared, and the right is 11. So the problem above was kind of nice because it went ahead and added the plus 9 and it had equals 11. So we were ready to factor and take the square root and move on. But sometimes the problem doesn't give you the plus 9, and it hasn't been set up as a perfect square. So you have to complete the square. You have to figure out what number goes here. That's all for this page. Go to the next tape for the next page.